Emergency lights are going off, sirens blaring. The spaceship is shaking like crazy. The cosmic darkness beyond the portholes is illuminated by pulsating flashes. The astronauts are strapping themselves in and looking at the screens, cold sweat breaking on their foreheads. Straight ahead, space is cut in half by a blinding beam. Nothing in the universe can stop it. It looks like a humongous airplane jet stream, millions of times more powerful than any jet could make. There's no way to go around it. The leader of the space expedition orders everyone to turn around immediately. That was a black hole jet, a real monster of space. The holes, like huge vacuum cleaners, swallow everything that falls beyond their event horizon, the boundary between space-time and the place where it disappears. If you find yourself close to this border, you're doomed. Even light can't escape the gravity of a black hole, and it's the fastest thing in the universe. The holes not only absorb matter, but also shoot jets into space, mysterious beams thousands of light years long. There are no black monsters near the Earth, but let's imagine if one suddenly popped up close to the sun. The hole immediately starts devouring the star. Strong gravity pulls one side of the sun more than the other. The hole tears the sun into ribbons, eating it just as you would eat spaghetti off your plate. Physicists call this phenomenon spaghettification. When the monster's finished its meal, it hiccups, and, like laser swords, two jets cut our galaxy in half. Astronomers are observing a similar catastrophe right now, billions of light years away from us. A black hole from the 3C321 system is bombarding a nearby galaxy with a jet of X-rays, gamma rays, and electrons accelerated to the speed of light. The onslaught has been going on for 1 million years, and we're lucky it's taking place at a safe distance. If a jet comes close to a planet similar to Earth, it'll vaporize the atmosphere and the ozone layer. All life on the surface will disappear. Only deep underground dwellers will survive. If a black hole does appear next to the sun, though, we won't live long enough to see the jet. The monster will absorb the energy of the star, and we'll simply lose all heat and light. The Earth will cool down, delving into eternal darkness. But, like anything else, jets can do good things too. Like fertilizers helping crops to grow, the energy of the rays squeeze the space clouds, and new stars will be born from them. Imagine a drain in the bathroom through which water flows into a pipe. The water moves in a spiral, and some of it rotates around the hole. Now imagine that the black hole is the same drain, and instead of water, there's the stuff called plasma. It spins rapidly, gets magnetized, and collects into a huge accretion disk. Plasma starts to glow, and at some point shoots two streams into space. The black hole V404 Cygni lies 8,000 light-years away. It's like a firework display that weighs as much as 10 suns. The problem is, they forgot to install it securely, and the wick was prematurely set on fire. The hole is powered by gas from a nearby star. It provides infinite charges for the space fireworks. The V404 Cygni jets don't just fire from the poles, but in every direction. A disk as wide as 7 suns is spinning around the black hole. The inside of the disk is wobbling like a top that's about to stop spinning and fall. Scientists believe the wobbles and random shots are caused by distortions of the space-time continuum. Black holes are not the only ones who know how to put on a space show. Their main competitors are gamma ray bursts. Science doesn't know exactly how they appear. Most likely, it's because of the decay of a huge star or the collision of neutron stars. Satellites record one gamma ray burst every day, but at least 500 outbreaks occur in the universe within the same time period. An amateur astronomer first seeing the observable universe may feel like a movie star on the red carpet. Only they'll be blinded not by the lights from the cameras of journalists and fans, but by constant gamma ray bursts. If there is a flash near the Earth, our planet will feel like a candle in a snowstorm. Imagine that you live in the future and can take off on safe interstellar flights. On your spaceship, you fly to a planet that looks like Earth to see a gamma ray burst with your own eyes. Your ship is cutting into outer space and landing on the planet in question. As soon as you step on its soil, though, you feel it. Every living thing in this world is waiting for something terrible to happen. Frightened birds are flying through the sky. Animals start running out of the forests and looking for shelter. The wind makes the leaves rustle, and it's like they're whispering to you, "Save yourself, get out of here." Then, the wind grows stronger and turns into a storm. A bright flash appears on the horizon. After a few seconds, the light intensifies. Someone huge has turned on space floodlights. Everything is lost. There is only light. As much energy is released in 1 second as our sun generates in 10 billion years. 10 seconds pass and the show is over. The planet is moving through space, and the flash has only hit a part of its southern hemisphere. But that's enough for things to go badly. The gamma ray burst was a pretty short one, so it probably wouldn't have vaporized the oceans or blown away the atmosphere. But the ozone layer, which protects the planet from the rays of the nearest star and cosmic radiation, still disappears. All life in this world abruptly ends. The picture is terrible, but there's no need for us to panic just yet. Scientists believe the probability of a similar catastrophe on our planet is 0. But the Earth hasn't always been so lucky. The Ordovician extinction occurred 450 million years ago. Perhaps a gamma ray burst was to blame. Its epicenter was 6,000 light-years away from Earth. Harmful UV light hit the planet's surface, reducing the ozone layer by 40%. More than half the plants and animals disappeared. But life continued to develop, and after 200 million years, dinosaurs began roaming the planet. Eta Carinae is a hypergiant double star. It's almost 200 times heavier than the Sun, and in 10 seconds, it emits as much light as the Sun in a year. It's as far as 7,500 light-years away from Earth. But in 1843, dwellers of our planet saw it in the night sky without telescopes. This was possible thanks to an explosion. These beautiful clouds of gas and dust are the consequences of those events. We can say these are huge ruins of a star, but they look cool. Over the next 1 million years, Eta Carinae will continue exploding and form a gamma ray burst. But even here, humanity needn't worry. The direction of the gas clouds indicates that the future burst beams won't hit the Earth. Our planet is under siege. Right now, 30 million space objects, varying in size from a grain of sand to a car, are flying towards the Earth. But our atmosphere burns all border violators. Scientists are constantly monitoring space, and they haven't found a single space rock potentially hazardous for humanity. But this doesn't mean it doesn't exist. A huge asteroid arrives to Earth once every 2 million years on average. Here are the surfaces of the Moon, Mars, and Mercury. Craters cover them like cheese holes. These are the tracks of asteroids that have been bombarding their surface for millions of years. An atmosphere is an excellent barrier against the rock shower from the skies. But every year, around 500 large objects still make their way through it. Most of them fall into the ocean or sparsely populated areas and remain unknown. Geological activity continues on the planet. The continents move, mountains rise and fall. As you watch this video, the landscape of the Earth is changing. All of this erases all traces of meteorites that have fallen on the planet.
Somewhere, deep underground in super-secret laboratories, scientists are trying to create a black hole. It looks like the latest experiment was a success. The black hole hovers above the desk for a moment, but then, in a split second, it swallows it whole. Uh-oh. After its meal, the black hole grows until it is out of control. Microscopes and test tubes fly into the dark void. Soon everything in the room has been consumed. Each time it eats, it grows bigger and bigger and attracts even larger objects. On the surface, people go about their day as usual. Some joggers stop their run when they see a giant black sphere growing in the distance. Houses are torn from their foundations, and cars fly through the air towards the black abyss. In just a few minutes, the black hole has enveloped our entire planet. Then it grows big enough to consume the Moon and Mars. The black hole is now heavier than anything in our solar system. All of the planets begin to circle it before becoming food for the monster. Finally, even the sun is extinguished in the belly of the beast. Well, that was pretty bleak. Don't worry, this isn't how the scenario would play out in real life. Our scientists may actually be capable of creating a black hole, but it's far safer than this. The effort to make a black hole is led by the scientists working in Geneva on something called the Large Hadron Collider. This machine basically makes particles move at high speeds until they collide. When this happens, they release a lot of energy and create a lot of interesting effects. Scientists think that energy released by these collisions might be enough to create a black hole. Some people were so worried by this that they even tried to ban the construction of the Large Hadron Collider. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat like a furnace. That means that they will fade away when they run out of fuel. If one appeared in the experiment, it would instantly burn out and disappear in a billionth of a second. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take about 500 billion years to gain a pound of weight. Black holes could actually be really useful. One with the mass of Mount Everest would emit enough energy to completely power humanity. Even better, black holes are so dense that the one this big would only take up a tiny bit of space. We couldn't create anything as enormous as the naturally occurring black holes, though. Some can weigh hundreds of thousands of times as much as our Sun. Recently, scientists have observed a real black hole feast. The sight of a black hole tearing an enormous star apart is one of the most mesmerizing sights in the universe. Heavier and more destructive than anything else in existence, the black hole is both amazing and terrifying. And black holes aren't actually black at all. They're so massive that even light can't escape their pull, meaning that they're actually invisible. Scientists can only find them with special instruments. Most natural black holes are born as stars reach the end of their lifespan. You can picture healthy stars as giant furnaces that burn hydrogen and give off unbelievable amounts of energy. Every second, stars like our Sun produce more energy than humanity has ever produced, which pushes outwards and makes it want to expand. This is what eventually finds its way to Earth as the heat that birthed life on our planet. The only thing stopping this expansion is gravity, a force that basically just pulls objects toward something heavy. Most people know gravity is something that keeps us planted to the ground and stops us from flying off into space. The force of gravity of a star is so strong on stars that it makes them want to implode in on themselves. So, when a star is healthy, the force of gravity pushes inwards, and the energy it releases tries to inflate it like a balloon. These forces mostly cancel each other out and stop it from doing much at all. When a star burns through its fuel, though, nothing is pushing outwards to stop it from collapsing in on itself. Some really big stars make so much energy that they gradually expand into something called a red giant. When they run out of fuel, they cool, and gravity pushes the enormous object into a tiny space. Scientists use our sun to measure how big things in space are. Our sun weighs 1 solar mass. If a light star, like our sun, implodes, not much happens, which is lucky if you've ever worried about being swallowed up into a black hole. If a red giant around 10 solar masses implodes, though, some incredible things can happen. The collapse of one of these is so intense that it explodes into a supernova, releasing a light as bright as the entire galaxy. Stars that are massive enough to produce supernovas sometimes become black holes. Their weight causes gravity to push down and compact them until they collapse into a black hole in less than a second. The inside of a black hole is mysterious and unexplored, for obvious reasons. One thing we do know is that they're so massive that they can even distort time. 1 second near the black disk can be equal to weeks or even months on Earth, depending on its size. In 2019, scientists watched a black hole devour a star the size of our Sun. Even though it was 860,000 miles wide, the star was completely trapped in the black hole's gravitational field. For a while, they danced around each other, gradually coming closer and closer. Eventually, though, the star was extinguished in the invisible mouth of the black hole. The black hole sometimes releases beams of energy into space. Sizzling plasma flies out at 6,200 miles per second as the black hole finishes destroying the star. About half of the star's mass is consumed, while the rest is ejected into space. Incredibly, these insatiable titans even consume other black holes when they get big enough. The collision of 2 black holes was recently witnessed by scientists when one, weighing in at 85 solar masses, met another that was 66 solar masses. When black holes interact, the bigger one always swallows the smaller, adding even more mass to itself. The resulting black hole here reached 142 solar masses big. It's hard to believe, but this is still very small for a black hole. It will continue to consume everything around it and might even reach the size of a supermassive black hole at some point. These are unbelievably big and destructive. Our entire galaxy, the Milky Way, rotates around the gravitational field of one of these supermassive black holes. This monster weighs around 4 million solar masses, or more than 1 trillion times our planet. And that isn't even the biggest they get. It's also theorized that black holes can be made without a dramatic explosion. Big gas clouds that weigh hundreds of thousands of solar masses could condense under the force of their gravity to make a star. This object would already be so heavy that it would continue to compact until it became a black hole, skipping the supernova stage. Supermassive black holes are so far away and hard to observe that scientists doesn't have a full understanding of them yet. We don't know much about what happens inside a black hole, leading to a lot of speculation. For decades, people have theorized about how we could use black holes. Knowing that black holes distort time means that someone could use it to travel to the future with the right technology. If it was possible to build a ship strong enough to withstand the powerful gravitational fields, it would be simple. All they would need to do is decide how far they want to go and fly around the outside of the black hole. In the few minutes or hours they spent near the time warp, years could have passed back on Earth. They could be thousands of years old without having aged at all physically. Wow, that's officially a mind-blower. Wow, the great day is finally upon us. The record-breaking hole-boring team is finishing their job today. Spectators have gathered from all parts of the continent just to look at the greatest borehole in the world. And even the Guinness World Records Commission is officially dumbfounded. The hole is more than 1,000 miles in diameter and goes almost as deep as the Earth's core. No one achieved this depth before. But wait, what's going on? People all around suddenly begin fainting. More and more of the spectators fall unconscious on the ground, their faces white. Did the diggers hit some dangerous gas pocket? Oh no! We're getting messages from all over the world that people start falling just where they stood. What in the world is happening? Ugh. So, this is the scenario you get if you dig a hole in the ground deep and wide enough to fit the whole atmosphere inside it. Let's explore. The atmosphere goes really high up, getting thinner and thinner the higher you rise. For example, on the ground level, you can breathe freely, while on top of Everest, you won't be able to survive for long if you haven't had a good training course beforehand. The air on the mountaintops is much thinner, and so it's a lot colder and harder to breathe there. If you rise even higher, say to the altitude where airplanes fly, you probably won't be able to breathe at all. That's because they have oxygen masks on board. If the plane loses its inner pressure, the air from the outside will rush in. And since it's too low in oxygen for your lungs, you're likely to lose consciousness very quickly. All that doesn't mean our atmosphere ends there. In fact, it goes far beyond. And some scientists say it could even include all the distance to the moon and even further. Oxygen molecules from the Earth's atmosphere can be found at massive distances. Although there are so few of them, you won't be able to use them anyway. And the furthest range the atmosphere goes is almost twice as far as the moon. But those are no more than tiny specks of hydrogen at that point. Now, if we somehow compress all this volume into a relatively small bubble around the planet, it would be about 6 miles above the ground, roughly the height at which commercial airplanes fly. Any higher, and there's big cosmic nothing called vacuum, where no airplane would be able to navigate. Next step? Fitting this mass of air into a hole in the ground. For starters, the entire volume of our rather thin bubble is only enough to fit into a 1,000-mile cube. This is just a little smaller than the Earth's core, and a side of such cube is about a third of the United States east to west. And here's the first serious problem. No one has ever dug a hole that deep, or wide for that matter. The deepest human-made hole in the world is the Kola Super Deep Borehole, and it's only going about 7 miles down. The drilling stopped because of unexpectedly high temperatures. Drilling and digging, though, are different things. The Kola borehole is only 9 inches in diameter, while what we need is to take a supermassive chunk out of the Earth to fill it with air. Still, at about the same depth, we'll face the temperatures of around 350 degrees Fahrenheit, and the deeper we go, the hotter it'll get. The Earth's core lies at 1,800 miles, so to dig that cube, we'll need to go more than halfway to the center of the planet, where the temperature will reach almost that of the Sun's surface. And that's not considering the time we'll need to dig that deep. Anyway, let's assume we have the equipment that can withstand such heat. As we go down, the air fills the pit and slowly leaves the atmosphere. And as it gets deeper, the pressure on it grows too, making it take less space. In the end, with all that weight from above, we won't even need such a deep hole, right? Nope. The high temperatures in the Earth's innards makes the air less condensed and compensate for the pressure. If the surrounding rock is hot enough, it will expand the air to such a degree where it will take the same amount of space as on the ground level. And when it gets even hotter than that, well, the air will actually take even more room than we've calculated. But we diggers aren't that easily daunted. The experiment continues with an actual 1,000-mile cube dug in the Earth's surface, reaching into the crust and mantle and almost to the molten core. The air expands from the heat and starts taking up more space, resisting its imprisonment. That's why we begin digging to the sides at lower parts of our hole. To compensate for the air expansion, the additional hollows span over 4,000 miles. That's about the radius of the planet. Finally, the air seeps down, leaving the atmosphere and filling the internal parts of the Earth. And still it won't stay put. Some of the air is yet on the surface, and everyone can still breathe, although it's becoming much harder. Turns out, to fill the pit with air, we'd need to dig so much that the Earth would just fall apart before we finish. But even now, the enormous hole we've made has changed the planet's center of mass, and it's now spinning and revolving around the Sun more slowly and awkwardly. Instead of pushing all the air from the atmosphere down below, we've caused a cataclysm that would destroy our planet much more quickly than the lack of breathing air. Okay, so let's rewind then. We can't dig a hole in the ground because the air just won't fill it, but stubbornly spills out, and eventually our planet will just be torn apart. And we probably can't dig through the ocean's bottom because the hole will get filled with water instead, and the air won't have the room either. And that's not saying anything about all the water that gushes down to the hot layers of the Earth, causing catastrophic reactions that will, you guessed it, blow the world to pieces. If so much cold water reaches the extremely heated depths of the planet, hot magma below will start releasing toxic gases into the atmosphere, suffocating any life on the surface. Oh boy. So, the only chance to fill the hole in the ground we made is to compress the air to a liquid state, almost like they do with scuba gear. The oxygen tanks are filled with super compressed air that allows divers to breathe for a long time using just a small vessel. Now, we could just fill several 100,000 of such tanks with compressed air from the atmosphere and throw them all into the hole we've dug out. The pile will only be several 100 miles high, so technically it's not possible. Or we could invent a really huge tank for just this one purpose, pump all the air from the atmosphere in there, compress it as much as possible, and then dump it into the ground. Congrats! Mission accomplished! We've dug a hole deep and wide enough so that all the air around the Earth fits inside it. Now, what happens next is all life on the planet stops breathing. Humans, animals, plants, even aerobic microbes can't survive without oxygen. So everyone and everything is effectively wiped out. Then, no more oxygen means no ozone layer either. The lack of this natural barrier makes the planet extremely vulnerable to the sun's radiation and cosmic rays. The flares from the sun stop warming the Earth and begin scorching it instead. The surface of the planet rapidly becomes an arid wasteland, bombarded with heat and UV rays. Next goes tectonic activity. With the temperature outside spiking, volcanoes start erupting all around the world, making it a churning mass of hot lava. Oceans boil and evaporate, mixing with toxic fumes and creating a thick blanket of black clouds. Ash and acid fall from the sky, covering the already scarred Earth. And finally, our former blue and green planet turns into a twin sister of Venus, the unbearably hot and inhospitable place where no life is possible. Well, this would not be a smart thing to do. So please, let's not try this at home. You want a super big hole? Try the Grand Canyon.